So here we have a vector valued function r, which is a function of the scalar parameter t. Using that, we need to obtain the values of the magnitude of the cross product between the first derivative of r with respect to t with the second derivative of r with respect to t, and also obtain the value of the scalar triple product between the first derivative of r, the second derivative of r, and the third derivative of r. So let us begin. So we'll start by noting down the value of the vector valued function r. So that's given as a times cosine of t. That is the x component multiplied to I cap, plus the y component, so that's a sine t multiplied to the unit vector j cap, and the z component is at times 10 omega. Here omega is also a constant. This is the z component multiplied to k cap. So omega is a constant. So this is equation number 1. Now what we'll do, we'll take the derivative of our vector valued function r with respect to t. And when we do that, we have three constant vectors here, I cap, j cap, and k cap. So we only have to do is take the derivative of their component. So derivative of a cosine of t, so that will be negative a sine t. This is I cap, plus a times cosine of t j cap, plus a times 10 omega k cap. So this is equation number 2. Again, we'll take the derivative of equation number 2 on both sides with respect to t. So this is going to give us the second derivative of r with respect to t. So that will give us negative a cosine of t I cap plus negative a sine t j cap plus a 10 omega. So that's a constant. So we have 0 k cap. So this is equation number 3. And we'll again take the derivative on both sides of equation 3 with respect to t. This will give us the third derivative of r with respect to t. So this will be equals to a sine t I cap minus a cosine t j cap. So derivative of 0 with respect to t, so that's 0. So this will be number 4. What we'll do, we will use equation 2 and equation 3 and find the cross product between them. So this will help us obtain the value of the first derivative of r with the second derivative of r, and then we will find its magnitude. So let's begin by first obtaining the value of the cross product between the first derivative of r with respect to t with the second derivative of r with respect to t. So that will be equals to, so we will use a 3 by 3 determinant, so that becomes easier to compute the cross product. In the first row, we have unit vectors I cap, j cap, and k cap. In the second row, we'll have components of dr over dt. So that's going to be negative a sine t. We have a cosine t and a 10 omega. In the third row, we have components of the second derivative of r with respect to t. We have negative a cosine t, negative a sine t, and 0. So let's expand this determinant along the first row. So this will give us, we have first I cap. So I cap is multiplied to a cosine of t times 0. So that's 0. Positive times a 10 omega times negative a sine t. So that will be a squared 10 omega times sine t minus j cap. So we have negative a sine t times 0, so that's 0. And we have positive a squared 10 omega times cosine t. This is the y component. And finally, for the k component, or the y is a z component, we have a squared sine squared t plus a cosine of t minus a cosine of t. So that will be positive a squared cosine squared t. Right. So let's rearrange it. So we have I cap, so that's a squared 10 omega times sine t minus j cap, so that's a squared 10 omega cosine of t plus k cap. Now here, if we take a squared as the common factor from these two terms, so a squared would be multiplied to sine squared t plus cosine squared t, which is an identity with the value of 1. So we have a squared. So this is the value of the first derivative of r with respect to t and the second derivative of r with respect to t. In the next step, so we'll label this as equation number 5 and we take their magnitude. To find out the magnitude, all we have to do is take the square root, and underneath the square root we are going to take each component, square it and add them to each other. So for the first component we have e raised to the power of 4 10 squared omega times sine squared t. For the second, this negative will become positive, so we have e raised to the power of 4 10 squared omega times cosine squared t plus a squared whole squared, so that will be e raised to the power of 4. That will give us e raised to the power of 4. So we'll take e raised to the power of 4 10 squared omega as the common factor from the first term and the second term. So that leaves us with sine squared t plus cosine squared t plus e raised to the power of 4. Right. So this will be e raised to the power of 4 times 10 squared omega. So this is an identity with a value of 1 plus e raised to the power of 4. Next, we'll take e raised to the power of 4 as the common factor. So this will be multiplied to 10 squared omega plus 1. Now 10 squared omega plus 1, that's a trigonometric identity with a value of secant squared omega. So that means we have a squared secant omega. So this is the value of the first derivative of r with respect to t and crossed with the second derivative of r with respect to t and its magnitude. Right. So we'll be using this to obtain the second part. So the first part is done. So we have a value a squared secant omega. Now for the second part, we have to obtain the value of the scalar triple product. We need to obtain the first derivative, the scalar triple product between the first derivative of r, the second derivative of r, and the third derivative of r. So by definition, this can be also expressed as we have dr over dt crossed with the second derivative. So we'll take the cross product between these two vectors and dot it with the vector, the second derivative of r with respect to t. Right. So we have already obtained this value. So we have to find the dot product between 5 and 4. So let's begin. So this will be equals to, so we'll only take the dot product of I cap with I cap, the j cap term with j cap. There is no k cap term in equation number 4. So let's begin. So we have a squared 10 omega sine t. So that's multiplied to a sine t. So that means we have a cube, and here there will be a sine square. Now for the second part, we have negative j. So we'll combine this to become positive a cube 10 omega times cosine squared t. So this is done almost. So we have a cube times 10 omega. So this is multiplied to sine squared t plus cosine squared t. So this value is equals to 1. So that means finally you can say that the scalar triple product will be equals to a cube 10 omega. So this is the final answer.